Hello. Hello, everybody. My name is Nicolò Pagan, and I'm a postdoctoral researcher at the University of Zurich. So today we will have a joint presentation with Joe, who's a PhD student in the same group. And we would like to talk about feedback loops in quantum systems. So we start with a very classical example about a bank that needs to decide to provide some loans. Obviously, they will try to do so by making a prediction through a machine learning model. But what I want to stress is that, and I think we heard some example this morning, is that this process of decision making will be sequential, so will appear multiple times in sequence. And one important aspect is that one instance of the decision making process will influence future ones. We had an example again this morning. So it's about, for example, you take the credit score as one feature of the individual in order to make a prediction whether they will be able to repay the loan. But potentially, this credit score might change after the decision has been taken. And this will carry over in the future instances of the decision-making system. So obviously, there will be some dynamics. And typically, people talk about feedback loops in this case. So it's I find that it's used as an important keyword, but I think there's a little understanding about what feedback loops are in this case. And they apply in many different domains. So not just on loan example, but also on user-defined systems. So here, the loop is that individuals are served certain content, which they may like it or not. But not just that, the fact that they will like it or not will create a feedback loop, because if they interact with the content, the same content will be shown again and again. And this might shape the opinions of the users. So in a way, it will create this sort of feedback loop in which the users will interact even more with similar and potentially polarized content. And of course, there's also one important aspect is that it relates to biases. For example, if certain types of individuals are typically shown certain content, this kind of feedback loops may reinforce the stereotypes. So in this talk, we would like to answer three different questions. The first one is, what is a feedback loop? Can we formally define it, or is it just a keyword? And second, are they different? Are there different types of feedback loops that occur in machine learning-based decision-making systems? And third, how do they eventually affect different types of biases? So let's start with the first one. What is a feedback loop? So we take a step back, and there is a whole theory, which is the dynamical system theory, that's defined with, or makes clarify what the system is, input and output. And this is a classical example of an open loop system, in which there's no interaction between output and input. And this is a closed loop system in which some part of the output information may enter as an input to the system. And this is what creates the feedback. Very simple, but I think it's important to clarify what a feedback loop is. And we'll come back with examples of what types of feedback loops occur in machine learning systems. So in order to do so, we need to be explicit. How can we define a machine learning-based decision-making system? So it took us quite some time to draw this diagram, but I think it was really helpful for us to make this exercise. So for now, there's no feedback. It's just an open loop system. Start from the left, we have some population, calligraphic eye, which enters the system. And the first block is a sampling block. So we typically have to sample one individual for which we'll need to take a decision. So let's say individual 9. This individual will have certain characteristics that we encode as theta, which contains both observable and unobservable features of the individual. Then we have a feature extraction block, which will say, okay, among the characteristics, let's say if we are talking about loans, we extract the credit score of the individual. And we may also extract protected attributes, which could be encoded in this page. And then we want to make a prediction. So given this X and possibly A, and through a machine learning model which is trained on previous data, we would like to predict whether the individual will be able to pay back the loan if this rent is below. So this y hat. And based on the y hat, we would like to take the decision, which is the. And when in parallel to this, there is an optimization y, which defines whether the individual will be, let's say, intrinsically able to pay the loan, independently on the prediction, independently on the decision. And with some delay, and especially if the decision allows us to observe this optimization, this new data could be presented into the machine learning model. So I'm saying depending on the decision because sometimes it's not possible to observe what's the outcome. For example, if the loan was not granted, you will never know for that individual if they would have been able to repay the loan. So, and now there are a lot of blocks, and now we can actually define what a feedback group in this case is, because the decision, which is our output, may enter as an input in different places, in different blocks. So, for example, I mentioned the credit score. So, this is just one possible example in which the credit score may change because of the decision, and we call this a feature group because it really changes the features of the individual. But then there are other examples. For example, in the recommended systems, we said that once we recommend content, this may shape the opinion of the individual. So this will actually change the individual characteristics, not just the observable features, which in this case could be their clicking history. Will really change what the individual thinks. And there are several other blocks, and then I will hand over to Joe for the rest.
All right, so in addition to the two types of feedback loops that Nicolò already introduced, we see on the slide that we actually have 5 in total. So let me just briefly give you one example for each of them. On the top left, you see what we call the sampling feedback loop. So in this case, the decision that is the output of the system feeds back into the sampling block. And one example for this could be, for example, a speech recognition system, such as Alexa, which has been shown to works for people that are non-native. So if they have an accent that is less understood by the system, it could lead to these people using such a system less and less. And the population that is using the speech recognition system would be more and more consist of native speakers. Another type of feedback loop that we identified is what is shown on the bottom right corner, which is what we call machine learning model feedback loop. So this has also been referred to as machine learning with partial or limited feedback, and it always occurs whenever the data that we can use to train a model depends on past decisions. So one canonical example for that would be a hiring case where the data that we can use to train an algorithm only knows, for example, the skills of people that were hired in the past, and we will never observe the skills of those individuals that we did not hire. And the fifth example of a different type of feedback loop is what we call the outcome feedback. One example for that could be the medical case where we use a machine learning model to predict the likelihood of death for critically ill patients. And now suppose that there's a patient that is predicted to have very high likelihood of death, and for this reason we give them painkillers. For the same patient, if we had a different prediction, which would have led to curative treatment, this patient would have survived. So in this case, it is really the decision that is based on a prediction of an outcome that shapes the outcome that we ultimately observe. So while this framework with those 5 types of feedback loops might not be exhaustive, it is in fact consistent with what we see in the literature. So we did a literature search of about 50 papers that all investigate and simulate different types of feedback loops. And while they do not specifically use those names, they usually just call those feedback loops. And this leads to like the specific feedback effects often being somewhat hidden in the analysis. We see that all of those 5 types of feedback loops commonly occur in the literature. Now, at this point, it's really important to mention that these feedback loops are not domain specific. So different types of feedback loops can occur in the same domain, sometimes even simultaneously. And to showcase this, we ran a simulation study using the example of a recommender system, where we could have basically used any of the other examples that we've seen so far. So in this specific example, the idea is that there is an online platform that wants to show content to its users, and they use a machine learning model to predict the user's likelihood of clicking on some content. And based on that, they recommend certain content, and they do not recommend other content. So as Nicolò has mentioned before, in this case, we could see an individual feedback loop if whatever is shown to the users shapes their interests or beliefs. However, at the same time, if the content that users see leaves them, causes them to leave the platform, for example, if the news is not aligned with their view, we would instead see a sampling feedback loop, where the sample of individuals on the platform could become less and less representative of the overall population over time. Similar to the hiring example, also here there could be a machine learning model feedback loop, namely if the platform updates their model based on data that is shaped by past recommendations. And as similar to what we've seen in the lending example, there can also be a feature feedback loop every time when we use features of an individual that are somewhat affected by past recommendations, and these features are then used at a later point in time to do new recommendations for the same individual. And last but not least, also here in this recommender system example, we can observe an outcome feedback loop, just simply because if we have a ranked list of recommendations, users are much more likely to click on whatever shows up first on this list. So here we see a clear example of the decision of the system affecting the outcome it's trying to predict. So while we go into much more detail about this simulation example in the paper, we asked ourselves what happens to the individuals and to groups of individuals over time, and how is this related to biases. And for the sake of time, I'm just going to quickly present some very high-level insights of this simulation study, which you can see on this slide. So for both the sampling feedback loop and the machine learning model feedback loop, we see there is a clear relation to representation bias, simply because over time, as a result of these feedback loops, we could see the sample of people being active on the platform, and as a result of that, also the data that the platform accumulates, we could see that this is much less representative of the actual population over time. Now, a different effect can be observed in the case of an individual feedback loop, where we see a clear connection to historical bias, which could potentially be reinforced. So one example for this could be reinforced polarization over time if the content that is shown to user reinforces their beliefs or also their interests. Now, on the other hand, we see the feature feedback loop and the output feedback loop, which both do not affect the individual as such, but only the representation of whatever we can observe with regard to that individual. So both the feature and the outcome feedback loop are related to measurement bias, where whatever we can measure as a potentially decision relevant attribute of an individual either becomes closer or goes further away from the true attribute of the individual. Now, just to quickly wrap up, we've seen a few examples already in this presentation, and we provide a lot of different examples in the paper that clearly show that in machine learning-based decision-making systems, if we do sequential decisions, feedback loops are very likely to occur every time when the outcome of the system feeds back as an input into the same system. What we also show in our study is that these feedback loops can come in very different shapes, and this is important to consider because the resulting effects on individuals and group individuals can depend very much on specific feedback effects, and it can result in different types of biases. We believe that our framework is an important first step to be able to better analyze, measure, and in the long future, potentially even control the feedback loops in machine learning-based decision-making systems. And we also hope that we could move away from just looking at these systems in a static way and maybe inform development of bias mitigation techniques that also work effectively in the long term. So just before concluding, I want to mention that this is joint work with Ezzat Elokda, Giulia Pasquale and Saverio Bolognani from ETH, and also with Anikó from the University of Zurich. Thank you so much.
Let's take one short question.
I had a quick question. In this paper, for the feedback loops, are you making this distinction between the machine learning model predicting and making the decision, or informing a decision maker based on the prediction? And I'm curious if that distinction will also open a new array of feedback loops in this machine learning pipeline that you're discussing in the paper.
So we clearly model this differentiation between the prediction and the decision that is made based on this prediction. However, we don't draw the feedback loop that goes from the decision block to the prediction block. So we talked about this in a few times in our meetings, but we didn't find any of these instances in the literature that we read, but potentially in the future that could be something to further investigate.